Okay, I think it's best to motivate this with a simple example. Okay, so let's look at this 2 cross 2 example, which means that A is 2 cross 2. Yes, so 2 equations, 2 unknowns. It's easy to compute the solution to that, right? You'll take the second equation perhaps and solve x1 as a function of x2. You'll move x2 on the right side, sub that in first equation, and you're done with the solution for x1, and then you can replace it. But what we really want to do is we want to find a generalizable method which can go to n dimensions. So what Gauss elimination does is the following. It basically tries to, it takes this equation, which is the equation I just wrote down some time back, and tries to convert it into an equation which looks like this. A11, A12, that's untouched. It'll create a 0 here, and then there'll be A22 prime, X1, X2. B1 will be untouched, and then B2 will be B2 prime. So these are A22 prime and B2 prime are something which I will show you how to compute. But if this equation was suddenly reduced to that equation, this is much easier to solve. The reason is that if you look at the second equation is essentially A22 prime x2 equals B2, right? B2 prime. X2 is just B2 divided by A22 prime. That's it, right? Once you know the value of x2, so x2 is known, we can take the first equation. So the first equation is A11 x1 plus A. So this is step 1. The step 2 is to take that equation A12 x2 equals B1. I just wrote down the first equation here. We know x2. X2 is B2 prime divided by A22 prime, right? I just sub that in here, equals B1 prime. But now what we have in this equation is just one unknown, x1, because we've eliminated x2. And then here we got, here we have x1, we have x2, and so we've got the solution. So the goal here is to reduce this to what they call a upper triangular matrix. An upper triangular matrix is such that it always has zeros below the diagonal. Okay, and you could also do it the other way. You could have a lower diagonal matrix which would be zeros above the diagonal. You could solve it the same way. You have to go in reverse then. You have to start solving for x1 first, then go to x2. So if you could take this idea and go to any dimension. So if you have a big matrix like the one I showed here, something n by n, what you do is in successive steps, we'll try to reduce it to we need a diagonal square one. So let me split this. So Gauss elimination simplifies x equal b to this form. So that x is all over the place, but there are zeros in the lower diagonal, and then we have x1, x2, so on, xn, and then these b's need not be zero. So b1, b2 prime, b3 prime, so on till bn prime. The key thing is that there are zeros. So how do we do this sort of magic? How do we get to zeros in the lower diagonal? Okay, the way this is done is what they call a method called pivoting. we can illustrate it over here. If you wanted to create a 0 over here, what you need to do is, that is, you know, to make this turn into a 0, all you do is you divide this equation by a21, right? And then subtract, uh, sorry, you take the first equation and divide by a11, and then subtract, multiply it by a21 and subtract it from the second one. So let me just show you what I mean by that. So how do we do this? Do we do this? So here's how we'll do it. I'll rewrite those equations. So what we'll do is we'll take, let's call that 1 and 2. So we'll take 1, we'll divide it by a11. Okay, so a11. Then we'll multiply it with a21. So a21. So you've taken the coefficients of x1 in that fashion. So this is being multiplied with equation 1, and then take 2 and subtract that from 1. So what is that? What does that do? So a21, I'm just going to write it down as it is over here. So a21 x1 plus a22 x2. This, I just wrote this down as is, equation 2, minus a21 a11, that is this part, minus, times the first equation. Okay, so that's in the left-hand side. The right-hand side, you have to do the same thing. The first equation minus a21 a11 b2. So this part is right here. This part is this. So you need to do the same thing on both sides. So I did the same thing here, and then same thing here. So you notice what's happening now is that this and this will cancel off. Notice it. So when you multiply it, and then what you'll be left with is a22 minus a21 a11 a12 x2 equals b1 minus a21 a11 b2. So this thing here is your a22 prime, the one I wrote down earlier, and this thing is going to be your b2 prime. This is the new b, and that basically helps you solve for x2. Okay, so if this was still not clear, I guess sometimes it's not clear when you have these a's floating around. I'm pretty sure it'll be clear once I do the numerical problem. So we'll do a 3x3 example using exactly this method, and I'll walk you through how it is done so that we get an upper diagonal matrix. And then you'll see for yourself. So, okay, so let's do a problem which will further help us to understand this. One thing I want to mention here is, and this will come again and again, is that we use this one as a pivot. This is called a pivot. Okay, but the pivot is used to divide that equation. So what happens is, by using that as a pivot, we can actually ensure that everything below it, which has an x1, is eliminated. So here we've used the pivot a11 to eliminate x1 in this equation. There's no x1 because it was used. So the word pivot is kind of important. Okay, so here these are the pivots. All these are going to be the pivots in our calculation. Okay, and that's going to be important later on. What if there was an equation which did not have a pivot? What will you do? Okay, so that's an interesting question. We'll deal with it later on. So what I mean by that is, what if a11 was 0 there? You could have an equation without A11. There's nothing which stops A11 from being 0. So that's a problem, and that can be addressed too, but we'll get to that a bit later. Okay, so let's solve a problem, and that will help you understand how this works. Okay, so first we'll solve it by hand, and then hopefully write a code which will do it for us. So here is an example. Okay, so here's an example. Solve the following set of equations: 2x1 plus x2 plus x3 equals 7, x1 minus 3x2 plus x3 equals minus 2, and then 2x1 plus 2x2 minus x3 equals 3. So if anybody has a calculator, can you try to solve this? Just have to plug in the numbers. We tried solving it. If anybody on Zoom tried solving it, you can just put it in Octave, MATLAB, or a calculator, do A/B in Octave.
Yeah, x to equal 1, y to equal 2, and z to equal 3.
Perfect. Yeah, 1, 2, 3 is the answer.
Oh, sorry, x1, x2, x3. These are my variables.
1, 2, 3? Yeah. We basically cooked it up so that it's easy to remember. 1, 2, 3 is the answer. And why I'm doing this is because we have a solution which we got from a package. Let's see if we can get the same solution in Gauss elimination. So what we do is, in this case, we will write it in this fashion just to make our life easy. Instead of, you saw me doing that pivot and moving things around, writing 2 minus, that's just so hard. So we're just going to write it in this form. This is nothing but A and B, right? Just written down as it is, just copied to 2, 1, 2, that's copied here. 1 minus 3, 2, that's copied here, and so on, right? Super easy. Now what we'll do is we'll use the method, the pivoting method right here. So we have to use this one as the pivot. So we'll always work our way from column 1 to column 2 to column 3. So we'll use 2 as a pivot, and then try to eliminate the 1. So we want a 0 here, and we want a 0 here. So we try to eliminate those two to 0. So by using 2 as a pivot in row 1, column 1. Okay, so what we do is, so it's easy to see that to do that, you basically do row. So this is exactly the operation I did earlier. So I'm going to rewrite row 2. This is row 2. This is row 1. This is row 3. So row 2, my new row 2 is going to be my old row 2 minus the same strategy. What I had done earlier was I divided by A11 and then multiplied by A21. A21 sits here in the second row, and A11 sits in the first row, first column. So that A11, the pivot, is always divided, and you're multiplied it with A21. So here, what that means is the pivot is 2. So I write it here. And then this thing 1 sits here. And then I just do row 3. Sorry, my bad. Row 1, right? What is subtracted is always row 1, because the row 1, the pivot is sitting in row 1. Okay, so with that, we can try to see what it looks like. Now, the result of this operation, the first row is not affected. So you can write it as is. So 2, 1, 1, 7. Nothing happens to it. The row 2 will change because here I'm doing a calculation for row 2. It's equal to so and so. So row 2 is row 2 minus half row 1. So what this means is, and I'm going to be slow in the first time, but eventually I will stop writing it in detail. So let's see what this does. So we have row 1. sorry, row 2, I wrote down 1 minus half, this half times row 1, so 2. So that 2 came from here. Need more space. Next, we do row 2, so that is minus 3 minus half of row 1, that row 1 element is here, so it's 1. Next, we have 1 minus half row 1, so it's 1. And then we have to also do it on this side, so minus 2 minus half row 1, 7. Okay, so that's that. So that will, I need to do that calculation, but there's another thing I need to do, which is, remember, I'm trying to get more zeros. I'm trying to crank a 0 in here too. I want a 0 here. So I want a 0 here and 0 here. So I think I'll get a 0 here. You can see that's a 0. So I need a 0 there. So what I do is I do the same kind of method here. Row 3 is equal to old row 3 minus, again, take the pivot, divide, take the value 2, put it up, and then that should be minus row 1. So these are the operations. Okay, so nice thing is that I just have to do row 3 minus row 1 because 2 divided by 2 is 1. So I just do 2 minus, so 2 minus 2, this 2 and this 2. Then 2 minus 1, and then minus 1, minus 1. And then 3 minus 7. We're just preventing clutter. Okay, so let me take that and just write the values. Copy. Yes, so here it is. 2 remain as is. 1 minus 1 is 0. 2 minus 2 is 0. Then we have 1 will remain as is. So minus 3 minus half is minus 3.5. Two minus 1 is simply 1. The first, the 1 in row 1, column 3 remains as is. 1 minus half is half, so 0.5. Minus 1 is minus 2. Then we have 7. So minus 2 minus 7 divided by 2, that's minus 3.5. So I think it's minus 5.5. And then 3 minus 7 is minus 4. Okay, so that is, so to say, iteration 1. I've got what I really wanted, which is zeros in the first column. Okay, and then the pivot will not change. Now, next goal is to get a 0 here. And actually, I'm done after that. I just need a 0 there because I'm trying to diagonalize only the first 3 rows, 3 columns. It's only these 3 columns, right? So here I'll use the pivot is 3 minus 3.5. So this is the pivot. Okay, so here's something you cannot use. You cannot use 1 as a pivot. So don't use 1 as a pivot. If you use 1 as a pivot, you'll see that you'll basically end up creating a non-zero over here because you'll take this 2 and you subtract it here. So you only have one option to use minus 3.5 as the pivot because it has a 0 here. So using minus 3.5 as a pivot, we'll use the same idea as before. So we have a new row 3 will be the old row 3 minus, so always the pivot goes down 3.5 multiplied by this element here, 1, and this is row 2, because this row 2 is now my pivot row. So when you do that, you get 2, 0, 0. You'll see that the first column is unaffected. Okay, so this one will give you 1 minus 3.5 times row 2 minus 3.5. 1 is unchanged, 0.5 is unchanged. So you'll have minus 2 minus 1 divided by 3.5, and then 1 at 1, sorry, 0.5. And then finally, 7 is unchanged, minus 5.5 is unchanged. Okay, so last we'll have minus 4 minus, again, minus 1 divided by 3.5 times the row 2, so minus 5.5. Okay, so 2, 0, 0, 1 minus 3.5. This is going to be 0. You can check it out. So 0.5. So that I'm going to just write down. You can you can check my answer. It comes out to be minus 8.57, minus 1.857, and then 7 minus 5.5, and that is also minus 5.57. Okay, so that's it. That's what we were after. This gives me equations 2x1 plus x2 plus x3 equals 7 minus 3.5 x2 plus 0.5 x3 equals minus 5.5, and then minus 1.857 x3 equals minus 5.57. So from the last equation, let's call it 1, 2, 3. From 3, x3, so that's 3. From 2, we can sub in the value now, 3.5 x2 plus 0.5 x3, which is 3, equals minus 5.5. And solve for x2, comes out to be actually 2. And then from 1, we can have 2x1 plus x2 is known, 2. x3 is known as 3, 7. So 7 minus 3 is 4, minus 2 is 2. So x1 is 1. Okay, so our solution is what we found using a calculator. X1 is 1, x2 is 2, x3 is 3. Okay, so that's the back substitution. There are two parts to it. One is you do the pivoting and make it into upper diagonal matrix, and then you do a back substitution in the reverse order, x3, then x2, and x1. Yeah, it is a new chat. If not, then you can just click on this, it'll be a new chat. Yes, so it is a new chat. So I'm just going to make it do exactly what, well, I'm going to ask it the same question which I posed in the class, right, and see if I can get it to write the code. Okay, so write Octave code to for Gauss elimination to solve the equations. And it's kind of flexible about how you want to write it. So you don't have to even put 2 times x1. I'll try. If it doesn't work, then I'll change it. So 2x1 x2 plus x3 equals 7. And then x1 minus 3 x2 plus x3 equals minus 2. And then 2x1 plus 2x2 minus x3 equals 3. So augmented matrix, that's the same one which I showed you. It was like A and B put together. That's what it does. Then it does the forward elimination, which is the step which is creating the zeros. And then the back substitution is the one which I showed you. So those three steps are clearly in that code. So let's see what it is. So here it is. It has A, B. It augments A, B, the same one what I did. Then it does the, I think this one is the forward elimination step as it says here. And then it says the back substitution. So let's the first thing is, if it's giving you code, let's copy paste it and see what it does. And run this. Save it somewhere. Just save it on desktop. Change directory. There it is. So solution is 1, 2, 3. Now, if you the way you like to normally do this is just to write a separate function for the main file. That way you can change that and it's not part of this. So maybe we could do it that way. I guess the harder way is to write it yourself. The easier way is to make ChatGPT to do that. I like it that way because then you can change the main file to do a different system and get the solution. So rewrite the code. So split the code into 2 files such that one has a function Gauss elimination and the other one has the A and B matrices. So it's a function file. And then the main file. So this way, what we can do is if we have a different problem, we can just write a different A and B or have another file and then call that. So let's take it this way. So copy code. It's saved and then new. Let's it did not copy. See, it's copied now. I have to oh, I'm copying the wrong one. My bad. Here, copy code and okay. So main Gauss elimination. Okay, I think that I did not save it at the same place. Let's go to the desktop. Desktop. Yeah, I have it. Okay, so this is a glitch which we've seen before. So the best way to deal with this is to stop. What happens is it forgets the path where it is loading from, and I hope it'll work this time. So it's say add. So you just say add directory to path or change directory. Change directory is better. So it produces the answer 1, 2, 3. Now here's the thing. I don't know if this will work. I did not check it out, but I told you that it uses 2 as a pivot. What if we change the pivot to 0? I think it'll not work. It says NaN. So this one might have a solution. Let's do x equals a/b. So you see the solution actually is, let me run this again. So you see the solution is actually 1.1818, 2.544, 4. But it actually gives you not a number. This method fails because what it's doing is it's actually using this 0 as a pivot. It's dividing by 0, so it becomes 1 over infinity, whatever it is. It's, sorry, 1 over 0, so it's infinity. And so it just doesn't work. Okay, so I'm out of time, but what you can do is you could take this uh, this problem, put it in ChatGPT and see what it gives. It actually gives you, it will actually give you a solution where it actually does, it's called partial pivoting. What needs to be done is you look at 0, 1, 1, the first row, and you find the maximum of that for that column and exchange rows. Exchanging rows doesn't really change anything, it just changes the equation. So if you have equation 1, 2, 3, and there's a 0 in equation 1 first, you move the biggest one. So let's say that here 1 and 1, so it doesn't really matter. So you replace exchange 1 and 2, and then it's just a matter of changing the equations, and it'll work just fine. Okay, so that's called partial pivoting, which it can do. I just don't have the time. Maybe I can do it next time. But it should be robust to that.